Hi there. Today I'm going to demonstrate GK Mastermind. Guess the 4-color code in up to 12 rounds, and codemaker sets a secret code, and codebreaker guess it, and GK proof verifies feedback without revealing the secret. So before going into the demonstration, let me just quickly talk about the concept. So this is GK Mastermind on Stellar, which has trustless feedback proof for codemaker versus codebreaker, built with Stellar Game Studio, and on-chain game state plus GK verified feedback. So the problem on Mastermind is only codemaker knows the secret, and codebreaker can only guess it, and codemaker must give feedback, exact or partial, without revealing the secret and without lying. So this is difficult to do it on chain. Preventing lying is easy, but keeping it secret is difficult on chain. And solution is using GK for private secret plus trustless anti-lie feedback. Verify that exact partial feedback is correct without revealing the answer, and codemaker cannot lie about feedback. And contract accepts feedback only when proof public inputs match on-chain game state and proof is valid under the stored verification key. Okay, so this is the initial screen of Stellar Game Studio. So you can start playing game by prepare auth entry and share that one like with share URL. But you can also start doing the quick start demo here so that I can do the demonstration easily without switching the tab. So I can use this one for demonstration today. So after starting it, there's a two role, codemaker and codebreaker. So first, codemaker needs to create a secret commitment. And this secret commitment is not only the 4-digit, it is one-way hashed with salt. So codebreaker cannot do brute force on the on-chain state too. And codemaker can also make the duplicate colors do like this. But for now, I just make it like 4 colors like this. Codemaker create the commit. So this commit is basically hash of this 4-digit plus this salt. Now waiting for the codebreaker's guess. I can switch to player 2, and player 2 is codebreaker. So this codebreaker has to make the guess of that secret, and that secret commitment is on chain, but that is sorted and only verified with ZK proof. So codebreaker has to guess it. So maybe I can start from maybe just randomly do this and submit guess. And all game start and commitment code and submit guess, all transactions are on chain. You can also check those transaction detail in this tab. Maybe I can open it for now. Guess is submitted, so waiting for codemaker feedback proof, so I can switch to player 1. Codebreaker submitted this guess, and the guess is displayed this mastermind board here. Player 1, codemaker just submit the ZK proof feedback. The key point here is this is ZK proof, so codemaker is just giving the feedback. In this, there's a 0 exact match, color match, but the location is different for 3 cases, without revealing the answer of this secret. Getting back to the codebreaker can see the feedback here. So this white means partially correct. So maybe I can do only red first, and I create the submit the guess on chain again and go back to the codemaker, and codemaker can create the feedback about that is using the ZK, and there's a one match. Okay, so this is a good information for codebreaker. So which means user guessed this red, and that's exact match. So red is only here. So slot 1 must be red. Maybe how about like this? I don't know. Maybe there's a strategy, but I'm not familiar with this strategy, so I can just randomly guess and go back to player 1 and going back the feedback. Oh, okay, so there's a 2 exact match. This is a quite good information, and I used purple here, and I also used purple here, so which means highly likely purple or orange must be correct. Maybe I can do, just want to make sure which one is correct, so maybe I can just do it first and go back to player 1 and submit feedback again. Okay, I got 2 exact, so which means this red and purple is exact match now, and seems like this orange and yellow is also partially match, which means it's almost done. So I can make this yellow and orange here, so must be exact match. Let me try and go back to player 1, and oh, still not exact match. Okay, in this case, why? Okay, I thought this in number 2, I thought this red and the purple is mud, but actually yellow and the purple is mud, so I just guessed it wrong. So it's a very difficult game actually. Maybe I can finish the game by cheating, but actually user cannot cheat it because this information is hashed and stored on chain, and user have to use the ZK proof to verify that. Orange, red, yellow, purple, and submit guess. And so this is correct guess, so go back to player 1 and submit the feedback. Game ended by code breaker's win, and attempt used is 6 times. So basically a code breaker needs to guess within the 12 times attempt, so it depends on luck and the strategy. Okay, and in this architecture, so there's a contracts for game and ultra honk soroban contract. So game is managed in this contract plus on-chain verification for ultra honk, and circuit is created with NOR, and also there's a front end and back end to manage game UI and ZK proof stuff. And this is a sequence. So codemaker create secret and salt and create the commitment, and commitment is stored inside the smart contract with hash. And when codemaker create the feedback, user create the ZK proof about that the feedback. It is verified in on-chain, so this has game contract, get the public input from on-chain state and compare that, and also request root honk verifier to verify the proof, and then accept or reject the feedback. Then the information is put back into the front end. So end-to-end flow is using the auth entry setup with codemaker and codebreaker with the Stellar Game Studio, and then start game on-chain and commit code, submit guess, and submit feedback proof, and then contract update state, winner, and end game. And ZK public input is just like this. The point is proof is only accepted if input matches on-chain state. Verifier validates proof with stored VK. For the security note, secret is never posted on-chain, so the commitment on-chain is sorted and one-way hashed, and invalid tempered proof are rejected. Wrong feedback claims fail for the verification. Contract enforces round limit and role-based actions. Okay, so this is all about ZK Mastermind, and I hope you can have fun. And this is using ZK verifier, which only can be run on localnet. User has to do the setup process, and the setup process is all kept in this readme, so you can have the prerequisite and do the setup, deployment, and also has the integrate script to test all scenario, including the security check. And if you try the front end, you can also run server and game UI, and you can try the game on your environment. Okay, so this is about ZK Mastermind. Thank you for listening.